Hey YouTube, thanks for visiting. So in this session we are going to discuss the sufficient condition for extremal. Okay, so this session is going to be very important and very useful for the calculus of variation, because the sufficient condition for extremal in this chapter we have very deep concept and very neat and clean concept लगेगा यहाँ पे, ठीक है, क्योंकि कुछ concept ऐसा है जो कि मतलब बहुत conceptual है, ठीक है, ये मैं बता रहा हूँ यहाँ पे. So let's start, and before starting we are requesting you to all those who are new in my channel, those who are watching me for the first time, if the content is helpful then please like to this session, and those who are new you can subscribe the channel if you want to be, obviously. And let's start. Okay, and in this session also the Legendre condition and the Weierstrass condition for the sufficient condition for extremum, that is for the maximal and minimal, ये सब यहाँ पे डिस्कशन होगा, ठीक है. सो चालू करते हैं आज का सेशन यहाँ पे. So these are the previous lectures, and I make a complete lecture series on calculus of variation, and if the sessions, or when the sessions will be completed, then I will provide the link, or I will provide this PDFs or this content in my Telegram channel. You can also join my Telegram channel. The link of the Telegram channel will be in the description. Okay, so before starting, or before going to read the actual condition, that is actual sufficient condition, that is the Weierstrass condition and the Legendre condition, we are know what are the proper field and central field and field of extremal about the extremal. Okay, so this term is going to be very important, and this term will have, or this term have very deep impact on the calculus of variation, or on the extremal, on the existence of extremal, that is on the extremals of maxima or minima, extrema, that is extrema, that is maxima or minima. Okay, so let's start. So it says that a family of curves y equal to phi of x plus c is said to form a proper field in a given region D of the plane xy if and only if one and only one curve of the family passes through every point of the region D. Okay, so for example, inside the circle x square plus y square equal to 1, so this is the circle x square plus y square equal to 1, the family of parallel lines y equal to x, that is these are the parallel lines y equal to x, okay, x plus c, forms the proper field since any point of the above circle there passes one and only straight line of the family shown as shown in the figure below. So see, that means क्या है यहाँ पे देखो. So the only curve is only one and one only curve is y equal to x plus c, which are parallel lines and which passes through the circle what the x square plus y square equal to 1. So this is the proper field. Okay, now if we take the another example, on the other hand, if the family of parabolas y equal to x minus c whole square minus 1 inside the same circle x square minus y square does not form a proper field, since the parabolas of this family intersect inside the circle, that means these points are intersect the circle. Inside the circle there are intersection of the parabolas of the family of parabolas, that's why there are in this case this is not the proper field. Okay, so that means what, if there are a family of curves which are parallel and which are intersect only one curve. Okay, so it says that in the region D the plane xy if one and only one curve of the family passes through every point of the region D. ठीक है, बट यहाँ पर क्या हो रहा है, ये जो पैराबोलास एक दूसरे को इंटरसेक्ट कर रहे हैं, ये जो पॉइंट हो रहा है ना, ये पॉइंट्स में मतलब वो पैराबोलास का पॉइंट आ रहा है, ठीक है, सर्कल को पॉइंट छोड़ के भी, ठीक है. तो इन that's why this is not the case of proper field. Okay, now what is the central field? So if all the curves of the family y equal to x c, y of x c pass through the certain point x0 y0, that is if they form a pencil of curve, then they do not form a proper field in the region D. If the center of pencil x0 y0, पेंसिल ऑफ कर्व मीन्स देखो एक पॉइंट से मतलब बहुत सारे कर्व्स बन रहा है यहाँ पे, तो ये जो सेट्स ऑफ कर्व्स है इसको हम लोग कहते हैं पेंसिल ऑफ कर्व. ओके, एंड डू नॉट इंटरसेक्ट एनीवेयर इन द रीजन with the exception of the center of the pencil x0 y0, then the family y equal to xc is said to be the central field. Okay, so this is the definition of central field. If you confused, then you can watch or you can read these lines properly to pause the video. Okay, so this is the central field. Now we comes our main motto in today's lecture, which is the sufficient condition for extremal. Okay, so this is the just a small concept of central field, and if you want to learn this field concept properly, then you can see the book Calculus of Variation by Gols. Okay, Gols, Gols, I think this is the spelling, or I will provide the link I will provide the name of this book with the author in the description section, in the comment section. Okay, so you can check the comment or pin कर दूंगा मैं यहाँ पे, ठीक है. So you can check this book for your further or for your helping. Okay, so you can see this book else goals, ठीक है. So sufficient condition for extremal. So condition for functional I, this is equal to x1 to x2 f of x y y dash dx. So yx1 equal to y1 and yx2 equal to y2. Now it comes to the Legendre condition. So there are mainly we read two conditions. One is Legendre condition and second one is Weierstrass condition. But Weierstrass condition is the more general condition. Okay, and you can say that and I can say also that in the case of the problems, if you apply the Weierstrass condition, then you can do the problem more perfectly, or the problem should be more perfect. Okay, so see, let f x y y dash possess the continuous partial derivative f of y dash y dash. Let C be the curve of the extremal of the given functional which passes through px1 y1 and p2 x2 y2, p1 x1 y1 and p2 x2 y2. Also assume that the extremal of the curve C included in the field of extremal. So there the term use field of extremal. That's why we read first the subfield, proper field and the field of extremal. Okay, then the following table provides the sufficient conditions for the nature of the extremal of the given functional. So what is the table? So this is the table, nature of the extremal of the given functional and the sufficient condition. Okay, so you can see for weak minimum to be attained on the extremal of the given curve C, what is the condition? F of y dash greater than 0, strictly greater than 0 on the curve C. For weak maximum needs to be attained on the extremal on the given curve C, what is the condition? F of y dash is less than 0. Okay, on C. And the third one is for the strong minimum to be attained on the extremal on the given curve C, if y dash greater or equal to 0 at points close to C, and also for the arbitrary values of y dash. Okay, so at point close to C and for arbitrary values of y dash, इस दोनों लाइन का मीनिंग क्या है? इस दोनों लाइन का मीनिंग हम लोग थोड़ा वेट करो, ठीक है, मिलेगा इस दोनों लाइन का मीनिंग. And for strong maximum to be attained on the extremal on the given curve C, f of y dash less than 0 at points close to C and also for arbitrary values of y dash. So this line का एक मीनिंग है, ठीक है. तो ये जो दोनों लाइन का मीनिंग है ना, ये दोनों लाइन का मीनिंग हम लोग जानेंगे नेक्स्ट वाला कंडीशन में, दैट इज Weierstrass कंडीशन में. So that's why I say here that Weierstrass condition is a more general condition to find whether it is weak minimum, to see or to show whether it has weak minimum, weak maximum and strong minimum and strong maximum. And one more thing here, I think you also apply that. We always say if strong minima exist, strong minima implies weak minima or weak maxima. Strong implies weak. Okay, so why we say that, or is it actually true or not? So we see this after some time. Okay, so see, so that's why I say first that this lecture is going to be very important and very conceptual lecture. Okay, so because we just calculate f y dash, suppose f y dash I got 5, so this means greater or equal to 0 or greater than 0, then we say that whether it is strong maxima or strong minima, and we also say that it has strong minima also. So whether it is true or not, we check it, and here I take an interesting example in which you can see that weak minima exist does not implies the strong minima existence. Okay, does not exist the existence of strong minima. That's why this class is going to be very interesting class. Okay, and conceptual class also. So now we comes to, and that's why I do not take any example here, and after finishing the all the concept I taking the example here. Okay, so it says that consider the functional this one. So define E, this is a function x y y dash p, this is equal to f x y y dash minus f x y p minus y dash minus p into f p x y p. So you remind this formula or this E equation you can say. So this is known as the Weierstrass function. Okay, so this is the Weierstrass function we define here, and there are lots of stories, so I discarded that part because if we want to discuss here the whole concept, then this video is going to be very long video. That's why we skip that part and just taking here the term E. Okay, so because how E comes, so there is this long story and long calculations there, so we skip that part. So P equal to dy dx along the extremal of the field. The requirement that the function E be non-negative is a sufficient condition for the functional I has to be minimum along the curve C. So what is the actual condition to get the minimum along the curve C, which is the E, this E is to be non-negative. Okay, and this condition, that is the Legendre condition, is actually a special case. So सकते हो यहाँ पे special case of Weierstrass condition. This is the more general condition, and I say again and again that why when you get this type of problem to say whether the existence of strong minima, strong maxima, you always apply the Weierstrass condition. Okay, because this is the more general and more powerful condition. Okay, why? If you see the example, then you can clear this topic, because why I say this. So the following conditions for a functional I is to have an extremum along the curve to C are sufficient. So what is the condition? Now comes to this condition. So for weak extrema, or so for weak extrema, the conditions are C is the extremal curve satisfying the boundary condition. That means whether we calculate first, if you given f of this one, so first we have to calculate the extremal, and the boundary conditions are also given. So C is the extremal curve, so extremal must satisfy the boundary conditions, obviously, because when we calculate the extremal we use these boundary conditions. Okay, that means this is obvious case, and this extremal C can be joined in the field of extremals, can be joined in the field of extremals. This means these types of nature, so it can be joined in the field of extremal. Okay, that means the जो extremals होगा वो एक central field, मतलब field form करेगा. ठीक है, and the last and the final one for the case of weak extremum is that the function E x y z x y y dash p has constant sign for all points x y lying sufficiently close to the curve C. So this is the main line. The constant E, the function E has a constant sign for all points x y lying sufficiently close to the curve C, and arbitrary values of y dash that are sufficiently close to P. What is the value P? P is the, if this is y equal to c1 x plus c2, that is y of x c, x and c, y is the function of y and yc, then P is what? P is suppose the, you can say dy dx term. Okay, that means what is P actually, इसको क्या बोलते हैं, P is the slope. Okay, so P is actually the, what is P? P is actually the slope of the extremal. P is actually the slope of the extremal. Okay, so we take constant for all points x y lying sufficiently close to the curve C, and arbitrary values of y dash that are sufficiently close to P. Okay, so sufficiently close to the slope, that means that. So if e greater than 0, then there is minimum, and if e less equal to 0, then there is maximum. So this is not only the line, you can say just you calculate the line e, and if e greater equal to 0, then you say it minimum, and e greater equal less equal to 0, you say this is weak maximum. So these lines are these words are very very important. Okay, because why these lines are very important, if we see the example, then I think you will be clear, or you will be understand the concept, actual concept. So C is the extremal for strong case, strong extrema case. C is the extremal curve satisfying the boundary condition. Yes, this is also satisfying, this is also satisfied, and this extremal C can be joined in the field of extremal, that is this condition may be replaced also by Jacobi condition. And what is Jacobi condition? I just comes to later what is Jacobi condition. That means you can also say that this C is extremal, the second condition is also replaced by Jacobi condition, or Jacobi, there is a equation. If this equation satisfies, then we say that the extremal satisfies the Jacobi condition. And number C is the function e xy y dash p as constant sign for all points xy p lying sufficiently close to curve C and the arbitrary values of y dash. Here one term is missing. What is that? Y dash that are sufficiently close to p. So in case of strong extrema, this line or these words are missing. Okay, that are sufficiently close to p. That means if p or if y dash takes arbitrary values, suppose for any arbitrary values of y dash, e can be greater or equal to 0, or e may not have the constant sign for all points xy. Okay, that's why in case of this case, that is for any arbitrary value, e constant sign को नहीं रखेगा यहाँ पे, ठीक है, because यहाँ पे बोला था कि arbitrary values of y, but arbitrary कहाँ पे, ये जो close to p पर arbitrary हुआ, मतलब p का सपोज एक नेबरहुड लेता हूँ यहाँ पर मैं, तो p का नेबरहुड में ये मतलब y डैश आर्बिट्ररी वैल्यू ले सकते हैं, मतलब p का जो है p का नेबरहुड में, मतलब ये जो e एंड p का मतलब y डैश का वैल्यू एंड p का जो वैल्यू होगा, ये सफिशिएंटली डिफर करेगा इन द नेबरहुड ऑफ p एंड सफिशिएंटली क्लोज ऑफ p, बट इन दिस केस आर्बिट्ररी वैल्यू ऑफ y ये p का नेबरहुड में रहेगा, इसका कोई गारंटी नहीं है, ठीक है। तो सोचो यहाँ पे बहुत ठंडा दिमाग से, ठीक है। तो देखो यहाँ पे आर्बिट्ररी वैल्यूज ऑफ y डैश जो होगा, ठीक है, ये p का नेबरहुड में रह भी सकता है एंड नहीं भी रह सकता है, मतलब यहाँ पे कोई कुछ बोला नहीं है, ठीक है। तो इन दैट केस इफ e ग्रेटर देन 0 देयर इज मिनिमम, एंड इफ e लेस देन 0 देयर इज मैक्सिमम। यू कैन सी इफ e लेस देन 0 देयर इज मैक्सिमम। सो व्हाट देयर इज ए मतलब पेन एंड जो हेयर का डिफरेंस है, ठीक है, जो बोलते हैं यहाँ पे, मतलब बहुत डिफरेंस जो है ना बहुत अच्छा खासा, एंड डेल्टा एप्सिलॉन के रिगार्डिंग आप यहाँ पे मतलब कंपेयर कर सकते हो, मतलब एप्सिलॉन का डिफरेंस है, ठीक है। तो ये दोनों कॉन्सेप्ट में वीक एक्सट्रीमा की केस में एंड स्ट्रॉन्ग एक्सट्रीमा की केस में जो डिफरेंस है, मतलब वो बहुत ही डीपली सोचोगे तभी ये दोनों कॉन्सेप्ट क्लियर होगा अच्छे से, ठीक है। तो ये है केस, आई थिंक यू कैन अंडरस्टैंड, and if you are not understand this concept properly, then you can comment me in the comment section below, then I will take another example and I will explain this weak case and strong case, but I think you will be understand after watching the example. Okay, so let us take the example. So this example is very important example, and I think this example can be clear your concept properly. Okay, so see, each and every line of this example is very important. Okay, so examine the extrema of the functional I is equal to integration 0 to a y dash q dx, where y 0 equal to 0 and y a is equal to b. A and b are greater than 0. So here f is given, y dash is q, which is free from both x and y. Therefore the extremal, okay, are given by the straight line y is equal to c1x plus c2, and if we apply the conditions, given boundary conditions, then we get actually the extremal y equal to b by a into x. This is the extremal. Now an extremal can occur along the line this one. Okay, So it is clear, I think. Now the pencil lines y equal to c1x. Pencil lines means what? This y equal to bx जो है ये एक फैमिली ऑफ कर्व, मतलब जो है फैमिली ऑफ कर्व फॉर्म करेगा. तो फैमिली ऑफ कर्व होगा y इक्वल टू c1x, इसका हम लोग कहेंगे क्या? पेंसिल कर्व. ओके, with the center at 0 0 forms the central field including the extremal y equal to b by a x. That means what? Suppose y equal to b by x means these lines y equal to b by a into x, this lines. and ये जो लाइन है इस लाइन का मतलब इस लाइन का बोथ साइड में जो है एक सेंट्रल फील्ड फॉर्म करेगा. ठीक है, मतलब जो होगा फील्ड ऑफ एक्सट्रीमल्स. सो दिस इज द एक्सट्रीमल एंड these terms are also the extremal, these lines are also the extremals. Okay, so this is the family of curves or pencil curves, you can say. Okay, so define the Weierstrass function. What is the Weierstrass function? So e equal to f of x y y dash minus x f of x y p minus f p x y p into y dash minus p. So this is equal to, since here f is equal to what? F is equal to y dash cube. Okay, so f means what? F of x y y dash, this is equal to y dash cube. So that means f p f of, that means f of x y and p, this is equal to p cube, and f p of x y p which is equal to 3 of p square. Okay, so I just put here the values. So y dash cube minus p cube minus y dash minus p into 3p square. Okay, so if we break this, so y dash minus p into y dash square plus y dash p plus p square minus y dash minus p into 3p square, this is equal to y dash minus p, and this is the term. Then finally we get y dash minus p whole square into y dash plus 2p. So e is equal to this one. Okay, so this is the final case, final value of e. Okay, so now I write here e is equal to y dash minus p whole square into y dash plus 2p. So this is the value of. Now it says that along the extremal y equal to b by a into x, the slope of the function p is equal to b by a, because p equal to what? Dy dx, and dy dx means we get simply from here which is equal to b by a, which is greater than 0, because it is given that a and b are greater than 0. Okay, that's why p is greater than 0, and y dash takes on such values that are close to p by a. So here it says in the third condition, close, sufficiently close value. Okay, lying sufficiently close to the curve c. Okay, so here it is sufficiently close to the value of value takes, e takes the constant value for all x y, and lying sufficiently close to the curve c, this line. Okay, and sufficiently close to p, then e greater or equal to 0. Now this is square term, so this is obviously greater than 0 and greater or equal to 0, because why? If sufficiently close to p, then this y dash minus p is slightly greater or slightly less. Okay, because y dash and p value is almost similar value. Okay, that's why, and this is square term, so y dash minus p is either positive or negative by slightly difference. Suppose you can say y dash minus p equal to something epsilon or delta, this small difference. Okay, mod of y dash minus p का वैल्यू होगा ये ऐसा होगा. ठीक है, तो जो है then consequently sufficient condition for the weak hold. Weak means sufficiently close to p. Okay, so y dash का वैल्यू arbitrary होगा, in the sufficiently close to p होगा. ठीक है, तो consequently ये बोला है therefore there is weak extrema taken along the extremal y equal to b by a into x. So why weak? Because this our value of y dash is sufficiently close to this p, that's why e is greater or equal to 0. Okay, if y dash may takes on the arbitrary values, then y dash plus 2p may have arbitrary sign. Consequently e does not keep its sign constant, does not hold. Okay, so that means what? Suppose it y dash takes any arbitrary values which is a bigger plus value or bigger minus value, then e does not keeps its sign constant. बोला था यहाँ पे e constant sign रखेगा always. देखो यहाँ पर दोनों ही केस में बोला था e has constant sign for all xy, e has constant sign for all xy. सो इन दिस केस ई जो है क्या हो रहा है, सफिशिएंट मतलब कांस्टेंट साइन को नहीं रखा है, y का वैल्यू ये हो रहा है, तो y डैश प्लस p हो रहा है, may not have arbitrary sign, consequently e does not keep its sign constant, does not holds, and so there is no strong extremal along the line y equal to v by ax. सो ये आई थिंक क्लियर होगा। देखो एक चीज यहाँ से बोल सकते हैं, क्या बोल सकते हैं, ई क्या आया था यहाँ पर, ई इक्वल टू आया था वाई डैश माइनस पी होल स्क्वायर इंटू वाई डैश प्लस 2p। तो आप लोग मतलब सोचो कौन सी केस ऐसा हो सकते हैं जहाँ पे स्ट्रॉन्ग मिनिमा, मतलब स्ट्रॉन्ग मिनिमा एग्जिस्ट करता है। तो ये जो एग्जांपल आया यहाँ पे देखो आप लोग कि यहाँ पे वीक तो आया बट स्ट्रॉन्ग नहीं आया, ठीक है, वीक मिनिमम यहाँ पे आया, वीक मिनिमा, बट स्ट्रॉन्ग तो नहीं आया, स्ट्रॉन्ग नहीं एग्जिस्ट किया है, ठीक है। तो ये जो खेल है यहाँ पे है मेन खेल। तो देखो यहाँ पर क्या बोला, वाई डैश का जो वैल्यू आर्बिट्ररी मतलब ऐसे वैल्यू ले रहा है यहाँ पे जो कि ये वाई डैश सपोज प्लस लिया, ये तो ऑलवेज ग्रेटर देन 0 है, तो वाई डैश बिगर फ्रॉम 2p हो सकता है, मतलब पॉजिटिव सेंस से भी या नेगेटिव सेंस से। तो ई का जो साइन हो रहा है ये कांस्टेंट नहीं आ रहा है, तो यहाँ पर स्ट्रॉन्ग एग्जिस्ट नहीं कर रहा है, ठीक है, स्ट्रॉन्ग मिनिमा एग्जिस्ट नहीं कर रहा है। तो कौन सी ऐसी केस होगा जहाँ पर स्ट्रॉन्ग एग्जिस्ट करेगा, तो ये देखो कभी कभी जो ई का जो फंक्शन आता है सपोज वाई डैश माइनस पी एंड वाई डैश प्लस 2p, तो इसका भी स्क्वायर टर्म आ गया, तो यहाँ पर क्या होगा, यहाँ पर वाई डैश का जो भी वैल्यू आर्बिट्ररी प्लस हो या माइनस हो, since this is square then it should always keep same sign, that is sign constant, e का जो sign होगा वो constant रहेगा। So in this type of functions when we get, we say that it also have weak minima as well as strong minima, ठीक है। तो ये कॉन्सेप्ट क्लियर हुआ कि नहीं मेरे को कमेंट सेक्शन में ज़रूर बताइएगा, बिकॉज ये बहुत मतलब कॉन्सेप्ट बहुत डीपली है एंड ये मैं जो है बहुत रिसर्च करके यहाँ पे लेके आया हूँ, ठीक है, बिकॉज ये कंसेप्ट मतलब आप देखोगे यूट्यूब में कहीं पे भी आई थिंक प्रोवाइड नहीं किया है, ठीक है। एंड जैकोबी कंडीशंस क्या होता है यहाँ पर एक बोल देता हूँ मैं, तो जैकोबी कंडीशंस, सो आई इक्वल टू दिस इज द एक्सट्रीमल द जैकोबी इक्वेशन, सिर्फ यहाँ पे इक्वेशंस को बोल देता हूँ क्योंकि जैकोबी कंडीशंस यहाँ पे सेटिस्फाई करना हो ऐसे प्रॉब्लम CSIR में कम ही आता है या उसी भी एग्जाम में। तो इफ सेटिस्फाई मतलब देखना हो तो देखो f of y minus ddx of f y dash into u, what is u, u is the, this is the form of u, del y of the x c, that is y is a function of y x and c is the curve del c, and minus ddx of f y dash and u dash, this is product f y dash u dash, this is equal to 0. If this satisfied then we say that f satisfies the Jacobi condition, that is the extremal satisfies the Jacobi condition which is given in this second condition of this one. So the extremal C can be joined in the field of extremal, this is also replaced by Jacobi condition. So this is the Jacobi condition, okay. So this is the Jacobi condition, and if we take another example, so see this is the questions from 2016. It says that of CSIR, so it says that jy equal to integration 0 to 1 y dash square plus x square dx, where what y0 equal to -1 and y1 equal to 1 on y equal to 2x minus 1. So on y equal to 2x minus 1 means y equal to 2x minus 1 is the extremal, and also these two conditions are satisfied. So if we apply the Legendre condition here, so what f is equal to what, f is equal to y dash square plus x square, okay. So f of y dash this is equal to clearly 2, and you can say this is greater or equal to 0, so you can say or strictly greater than 0, 2 means strictly greater than 0, okay. So see from here you can say, or you can say that if y greater than 0 strictly greater than 0 means there is no y dash का क्या है, y dash का कोई डिपेंडेंस नहीं है क्योंकि ये तो कांस्टेंट वैल्यू आ रहा है, ठीक है। तो यहाँ पे हम बोल सकते हैं कि वीक मिनिमम तो एग्जिस्ट करेगा श्योरली, बट स्ट्रॉन्ग मिनिमम एग्जिस्ट करेगा, ये हम यहाँ से बोल सकते हैं क्या। दैट्स व्हाई आई से दैट Weierstrass condition is more powerful and more general condition. So we say that if strong exists, then weak exist. So why? This is why. So this why का आंसर क्या है यहाँ पे है, देखो ये जो है ये सफिशिएंटली आर्बिट्ररी जो है नेबरहुड ऑफ जो है क्या बोला है यहाँ पे आर्बिट्ररी वैल्यू ऑफ वाई दैट्स आर सफिशिएंटली क्लोज टू पी, एंड ये जो सफिशिएंटली क्लोज टू पी वाला पार्ट है ये तो यहाँ पर नहीं है, बिकॉज देखो ये मतलब एक्सट्रीम मतलब स्ट्रॉन्ग एक्सट्रीमर की केस में जब ई सेम साइन रखेगा, इसका मीनिंग क्या है, ये इसका मीनिंग है ये तो वीक की केस में भी रखेगा, ठीक है सेम साइन, क्योंकि वीक में पॉसिबिलिटी ज़्यादा है रखने का, क्योंकि ये यहाँ पे सफिशिएंटली y2 जो p केस है यह वीक में एक्स्ट्रा है, ठीक है, तो वीक में होगा तो स्ट्रॉन्ग में होगा, ये इसका कोई मीनिंग नहीं है, बस स्ट्रॉन्ग में होगा तो वीक में होगा, इसका मीनिंग है, ठीक है, तो इसका मीनिंग यही है, यहाँ से हम लोग बोल सकते हैं, ठीक है। तो देखो ये जो था प्रॉब्लम क्या था 2, इसको हम लोग बोल सकते हैं कि ये ग्रेटर इक्वल टू 0 भी बोल सकते हैं, तो ये यहाँ पे देखो एंड y0 इक्वल टू -1 एंड y1 इक्वल टू 1, ये तो यहाँ पे एग्जिस्ट कर रहा है, तो आई थिंक इसका ए एंड सी ऑप्शंस भी ट्रू था, ठीक है। तो आप लोग एक बार इस प्रॉब्लम को मतलब वायरस्ट्रास कंडीशन में चेक करोगे, ठीक है, ये देखो यहाँ पे जो है एंड इसको हम लोग बोल सकते हैं कि ये जो ए पे इसको जैकोबी कंडीशंस के चेक कर से भी बोल सकते हैं, ठीक है। तो जैकोबी कंडीशंस जो था ये था जैकोबी कंडीशंस, एक बार आप लोग चेक करके मेरे को कमेंट सेक्शन में बताइएगा, ठीक है। द एक्सट्रीमल सी कैन बी ज्वाइन इन द फील्ड ऑफ एक्सट्रीमल, सो ये जो जैकोबी केस में ये हम लोग मतलब एज्यूम कर रहे हैं कि वो जैकोबी कंडीशंस को सेटिस्फाई करेगा, तो दैट्स वाई ये स्ट्रॉन्ग एंड बोथ मिनिमम मतलब वीक मिनिमम बोथ को रखेगा, ठीक है। सो यहाँ पे एज्यूम कर रहे हैं कि वो जैकोबी कंडीशन सेटिस्फाई करेगा, दैट्स वाई द लीजेंडर, दिस इज द लीजेंडर केस, सो लीजेंडर इज द स्पेशल केस यू कैन बोल सकते हो यहाँ पे, ठीक है। सो इसका आंसर आप लोग एक बार चेक करके बताइएगा मेरे को। सो कैसा लगा ये लेक्चर, आई थिंक दिस लेक्चर विल बी हेल्पफुल फॉर यू एंड you learn something new concept about the field of extremal or about the sufficient conditions, about the extrema, about the maxima or minima. Okay, so if this lecture is useful, if the lecture is helpful, then please give a like to this session and obviously subscribe the channel. And if you do not understand any topics or any मतलब कुछ जगह आप लोग अंडरस्टैंड नहीं भी कर सकते तो आप लोग ज़रूर एक बार देखिएगा इस लेक्चर को दोबारा रिपीट करके, एंड देन भी आप लोग नहीं समझ सकते हो तो आप लोग एक बार बुक को ज़रूर देखना। आई थिंक बुक देख के आप लोग मतलब बहुत कुछ लिखा है वहाँ पे, बुक देख के आप लोग थोड़ा कंफ्यूज हो जाओगे, तो आप लोग इस लेक्चर को दोबारा देखिएगा एंड मेरे को कमेंट सेक्शन में ऑब्वियसली बताइएगा मतलब कहाँ पे गड़बड़ हो रहा है, ठीक है। तो मैं ट्राई करूँगा कि दूसरा एक लेक्चर भी बनाने के लिए, ठीक है, एंड कमेंट में तो ऑब्वियसली मैं रिप्लाई दे दूँगा, ठीक है। तो चलो भाई मिलते हैं नेक्स्ट सेशन में। इस सेशन थोड़ा लंबा हो गया आई थिंक, सो चैनल को मतलब ये जो सेशन है थोड़ा लंबा होना था, देखिएगा अच्छे से। सो थैंक यू, बाय बाय, मिलते हैं नेक्स्ट लेक्चर में।